In this lecture, what we will do is we will take a look at the last gas power cycle that we will consider in the course. And the name of that gas power cycle is the Brayton Cycle. And this is more commonly known as the gas turbine cycle, or used in gas turbine engines. So you can see gas turbine engines have a rather large range of power outputs, anywhere from on the order of 100 horsepower up to 100,000 horsepower for very large industrial applications. The gas turbine engine will talk at the end of this segment about some of the history of the development of the gas turbine engine, but one of the largest applications are for aviation, both military as well as commercial. And it was actually military aviation that drove the development of the gas turbine engine back in World War II era. Today, although they are used quite extensively within military, it's also used within commercial aviation. We also use gas turbine engines for electricity generation. Now, you would not use the gas turbine engine to produce base load. For that, you would use either a nuclear power plant or a coal-burning power plant or something like that. But for electricity generation, the place where we'd use the gas turbines is where we want ramping power. So we want to be able to kick in and provide power, for example, in the evening when everybody goes home and turns on their TV, turns on their lights, turns on their microwave, their stoves, whatever it is, when they're cooking dinner. That's the time when the electric utilities have to provide pretty much the maximum power, and consequently they will kick in gas turbine engines during that period to provide what we call peak load duty, or peaking power is sometimes what it's referred to as. And they'll use gas turbine engines there because they can turn them on and off in the order of, probably on the order of about 30 seconds or so, or to a minute. It's a fairly quick ramp up, unless you have them on continually, and then they'll kick in automatically. And then other places where they're used, transportation, they're used for gas pipeline transmission. So in Canada, we use these for the main transmission lines which transport natural gas across the continent. And we have compressor stations every 100, 200 miles along the pipelines. And those compressor stations are powered by industrial gas turbine engines. So gas pipeline transmission. And that would be the same in other parts of the world as well, where you would have gas pipeline transmission. Other applications, transportation. We mentioned air transportation, but there is also water and land. Some ships will use gas turbine engines, and some tanks also use gas turbine engines, military tanks. And the last application is for generic industrial processes. And this could be processes where you have the requirement for either work or electrical power. So you produce power with the gas turbine engine, and you also produce heat. So it could be for process heat, it could be for steam generation, a number of different applications. That would vary depending upon whatever type of process the gas turbine engine was serving. So you can see there are many, many different areas where gas turbine engines are used. One of the nice things about gas turbine engines is you can combust a variety of different fuels within them. And so we could be combusting natural gas, which mainly would consist of methane. You could have ethane and some of the higher carbon gases in there. And you can also combust light distillate oils. And consequently, economically, the gas turbine engine is good, because these fuels are a little less expensive than gasoline, for example. So they are not as sensitive as the internal combustion engine to the types of fuels that are combusted. What we're going to do now, we're going to take a look at one of the largest applications of gas turbine engines, and that is of commercial transport. And so we're going to see engines that are on airplanes such as the Airbus 330, 747, Boeing 777. These are typically large ducted turbofan engines that are powered by the gas turbine engine. So let's take a look at them. So as you can see from the application, we saw aircraft taking off and cruise, and then finally in landing. And the gas turbine engine has really enabled us to have a globally connected world by the fact that people can fly on those aircraft and move around the world very quickly. The development of these engines, however, is attributed to a couple of individuals. And as I mentioned at the beginning, these were developed in the 1930s, pre-World War II. And there were two individuals, two engineers, who really should be credited with the development of the gas turbine engine. One was in Germany, and his name was Hans von Ohain. And one of his gas turbine engines can be seen in museums if you get a chance to go to museums that have aircraft. The aircraft that I'm referring to is the Messerschmitt 262. And this was the first aircraft ever to have a gas turbine engine on it. And it was a fighter aircraft that was a little temperamental, but what I heard was that when the fighters would see the Messerschmitt 262 coming along, the propeller-driven fighters, the Messerschmitt 262 would move so quickly that it was like flying, in the air and then out of the air. It was moving so quickly with respect to themselves. The other individual who developed was in the UK, and his name was Frank Whittle. And independent of one another, although perhaps they would have known about one another through any kind of agencies that are looking for investigation of what the other sides were doing during the war, the ramp up. But independently of one another, they developed the gas turbine engines, and we to this day benefit significantly from all of the work that they did in developing these engines. So that provides a bit of an introduction to the gas turbine engine. The next thing that we're going to do is take a look at the cycle and the process diagram for the gas turbine engine.